Hi, this is Sam and Josh, and today we will be showing you how to graph a hyperbola. So for a horizontal hyperbola, the form is x minus h squared over a squared minus y minus k squared over b squared equals 1. The center is hk, and the vertices is h plus or minus a k, and the asymptote is y equals plus or minus b over a times quantity x minus h plus k.
Now for the vertical hyperbola, the form is slightly different. It is quantity y minus k squared over a squared minus quantity x minus h squared over b squared equals 1. The center is still hk. The vertices is hk plus or minus a. The asymptote is y equals plus or minus a over b times quantity x minus h plus k.
So now we'll be doing an example problem for the vertical hyperbola. So now we have the example problem. We have the equation 16y squared minus 25x squared plus 64y minus 50x minus 361 equals 0. Now to make your life easier, you want to put the y's together and the x's together, and you need to put the constant on the other side of the equation. So now you get 16y squared plus 64y minus 25x squared minus 50x equals 361. So now you need to factor out a coefficient from the y and the x. So you can factor out a 16 from the y to get 16 times quantity y squared plus 4y. And then you can factor out a 25 from the x's to get 25 times quantity x squared minus 2x equals 361. So now you need to complete the square. So for the y, you do 4 over 2 squared to get 4. And for the x, you do negative 2 over 2 squared to get 1. So now when you add it to the constant, you need to multiply that number by the coefficient that you factored out in the beginning. So you need to multiply 16 by 4 to get 64, and then negative 25 by 1 to get negative 25. So now you add 4 to the y and the 1 to the x to get y times quantity y squared plus 4y plus 4 minus 25 times quantity x squared plus 2x plus 1
Equals no space, so here.
So you get 361 plus 64 minus 25. So now you can factor the y and the x and then add up the other side of the equation. And now you get 16 times quantity y plus 2 squared minus 25 times quantity x plus 1 squared equals 400. And now you divide the entire equation by 400, and you get quantity y plus 2 squared over 25 minus x plus 1 squared over 16 equals 1. So now we have the equation in the form we wanted. So we can refer back to this. The center is hk. So the general form is y minus k squared and x minus h squared. But for the equation to be y plus 2 squared, that means the k has to be negative so that the negatives cancel out. Same thing applies for the x. Since it's x plus 1 squared, that means h has to be a negative so that the negatives cancel out, which leads to y minus minus 2 squared and x minus minus 1 squared. So meaning the center is
negative 2.
No, negative 1.
And negative 2. Just kidding. Negative 1, negative 2. Sorry.
Okay. So we can go back to this, and the vertices is h, k plus or minus a. So now I have to solve for a. So a squared is the denominator that's always under the positive term, which is the y in this case. And b squared is a denominator for the negative term, which is x. So then b squared is 16. So now we can solve for A, which is 5, and B equals 4. So the vertices is that. So
it's -1 and -2 plus -5. Then we can -1 and 3, -1 and -7.
So those are your vertices. And now that you have A and B, you can find the equation for the asymptote. So now you have A, B, H, and K. And the equation for the asymptote for a vertical hyperbola is y equals plus or minus A over B times quantity x minus h plus k.
Now we take the values from up here, A, B, H, K, and substitute them into the equation. You get y equals plus minus 5 over 4 times quantity x minus -1. Since that's a double negative, it's a positive 1. Minus 2.
So now you have the equation for the asymptote, and now you have to graph the asymptote and the vertices on a graph.
Okay, now that we have our equations for the asymptotes, we have graphed them for you. Now, the scale is by 2 and 5. So this is the center right here, which is, wow, okay. What's the center? The -1, -2. Stupid. Okay, now we also have to plot the vertices, which was -1 and 3. That's right here. And -1 and 7. Or -7, sorry. Right here. Now we put the hyperbolas on this point right here and make it so it goes towards the asymptotes. So it would be like that. Except they don't ever touch, theoretically. The parabola, or the hyperbola line, and the asymptote line. And same for this side. Wow, okay. That's a terrible line. But you get the point.
And that's how you graph a hyperbola.